With static routing, you have to type in all the routes yourself into the routing table. With dynamic routing, the routers will update each other. Let's set this up in routing and remote access. So in this scenario, we're going to have two routers, and we're going to enable both routers to use RIP, Routing Information Protocol. On the first server here, in your RAS console, you need to right-click General, which you'll notice is under IP Routing. And we'll choose a new routing protocol, and we'll add in RIP. Now, whenever you add a routing protocol, you also need to right-click and specify on which interface for this computer will actually use the protocol. I've only got one NIC card in this computer, so that's the one interface we'll use. And let's take a look at some of the RIP properties here. For the operation mode, the default is periodic update mode. Now that's when one RIP router will update all other RIP routers via the next field here. So for outgoing packet protocol, the typical setup for RIP is actually broadcast. So what this means is this router will be broadcasting periodically its routing table. We've got two versions, so you gotta be careful about what kind of RIP routers you have in the network. Version 1 does not support subnetting, does not support VLSM, variable length subnet masks. You would only use that for backward compatibility. So worst case, then you should probably be using version 2 broadcast. Even better, you can choose version 2 multicast, and that information will just go to other RIP routers then. Let's specify RIP2 version 2 broadcast. And we can put a cost on our routes. We'll just leave the default one here for metric. With RIP routers, you can specify a password, and the RIP routers would have to have identical passwords to communicate with each other. That's clear text going across the network, so that's not very secure, but it is at least a level of security, if not that effective of a level of security. So I'm going to leave that off. Your other operation mode is called auto static update mode. Auto static update mode is typically used for demand dial connections where you do not want the routes to change. With auto static mode, once a RIP router gets a route from another RIP router, it stays in the routing table statically, even if you reboot the machine. Again, the point is for a demand dial router, you don't want them to lose the routes, so you leave it auto static update mode. With periodic update mode, it's dynamic, so the routing table will be started from scratch the next time the computer reboots. Going on to the next tab, the security tab, the point here is what routes will you accept from other routers. And the default is that you'll accept all routes. For security purposes, or actually for keeping your routing table slim and trim, you can say to only accept routes in a certain range. And that can be useful if you have a RIP router connected up to the internet. You probably don't want all the internet routes hogging up your RIP router, so you can certainly ignore routes in a certain range or accept routes only in a certain range. For this example, we're going to go ahead and accept all routes, and we'll go on to the Neighbors tab. Normally, RIP will broadcast or multicast out to a large number of computers, whether they are RIP routers or not. That's the one disadvantage, the big disadvantage of RIP, the broadcasting. Broadcast affects every computer no matter what, so what you can do instead is set up neighbors. And neighbors is when you specify the IP address of actual neighbor RIP routers. And you can say to use neighbors as well as broadcast or multicast, or you can say only use neighbors. In that case, you're really cutting down your traffic then because you're not broadcasting anymore. Again, for this example, we're just going to use a simple RIP scenario. We're going to use broadcast, and we'll go on to the last tab here. For the advanced tab here, the periodic announcement interval is how often the RIP router will broadcast out its routing table. So you want to be careful using RIP routers because, again, this is causing a lot of network traffic. Every 30 seconds it's broadcasting out, and the information is clear text, so HackerX can certainly capture your routes if they're so inclined. So even if you're using RIP, I'd recommend you increase this interval to a higher number so it's not broadcasting as much. It's not as chatty then. But for this experiment, it's actually going to serve us well to have a low announcement interval. So those are all your properties for the RIP connection. And I've just set up the one RIP router here. I'm going to set up the second RIP router then. Our second router will be computer 1. We'll open up routing and remote access. So we're on the second server now, and we can set up RIP on the second server. Just right-click General again, New Routing Protocol. RIP, okay. It's going to add it into the console here, and we have to add an interface. So we'll add local area connection. Once I add this in, it'll start broadcasting. So let's check out the situation with what I'm trying to accomplish here with the example. So on the second server, looking at the routing table, we have a lot of entries because we have multiple IP addresses set for this computer. Basically, this computer is a member of the 192.168.1 network as well as the 192.168.2 network. Switching back to the first computer, checking out the routing table of the first computer is only a member of the 192.168.1 network. It does not know about the 2.0 network. So that's what we're going to try to accomplish here. Through RIP, this first computer should find out about the 192.168.2 route. So we'll switch back. We'll go ahead and enable RIP here. We'll add the interface. We'll just leave all the defaults, periodic update. I'll leave all the defaults, and on the advanced tab, I'm going to drop that interval. Again, in the real world, you would certainly not want to do that. That's going to increase your network traffic quite a bit. Now it's broadcasting every 15 seconds. Okay, so we'll switch back to the first server, and we'll check out our IP routing table, and we'll just keep refreshing this. Okay, I've refreshed the routing table, and we now have the 192.168.2.0 route. That was not there before, and we'll notice the subnet mask, of course, is a Class C. The gateway is the other RIP router. So to get to that 2 network destination, this computer would go to the IP address of the RIP router, the other RIP router. And for protocol, you'll notice it says RIP, so you know you've gotten the information here from another RIP router. So that's a basic example of how RIP works then. The RIP routers will broadcast out their routing tables to each other and add routes.